Recording now. So bell ringer for today, we got the, let's see what it is. I kind of forget already what I wrote early this morning. Here it is. Describe the parts that make up the nervous system. Oh, yeah, so that is a long one. Also detail the 3 different types of neurons and their basic functions. So there you go. I'll give you some time to work on that. This one might take a little bit longer, so how about 5 minutes? Does that work, Hannah? Cool. Does Mr. Henninger have a pencil sharpener?
Yeah.
Oh, does he? Because 8th period, I think it was yesterday, Raven comes walking in and sharpens his pencil. I'm like,
we had a test or maybe that's one. Wait, did we? I don't know.
It might have been 2 days ago. I don't know.
We did have a test. Oh, yeah, we had a test 2 days ago. That didn't go.
Uh-oh. Was it tough?
Huh?
Was it tough?
Well, it wasn't that it was tough. It's that he makes them way longer than we have time for class periods. And he expects us to leave our 7th period classes early. And he tells us to. And I said, I'm not doing that. I have a college class. And everybody else does. And Mr. Ayers gets agitated. It's like he's asking for a knuckle sandwich. Mr. Ayers gets tired of it. I would too. But I don't leave my 7th period. Because we used to have this class first period last year for American History 1.
Okay.
And he'd always keep us after first period because the tests are too long. I tell him, tests too long. I asked him one time, I was like, can the test be done in 45 minutes? No. They shorten it. That gets on my nerves. So I had to leave for track. Usually I stay and I dilly-dally after school for a good half hour,
Yeah.
Talk to some of my teachers.
I see it, yeah.
And, but now that track started, I have to drive all the way to Millersburg, be changed and ready by a certain time to start practice.
Mm-hmm.
It was the first day of track practice, so I was like, I got there when the bell rang. So I got called to the office too. I had college algebra, go to the office, get to his class right when the bell's ringing, try to do my test, and I had to leave at a certain time. So I just ended up scribbling random stuff down because I literally did not have time to finish it.
So he doesn't give you more time, like the next day, or no?
I didn't ask. I was ready to
just
get out of there.
Forfeit it. Oh man.
He's a nice guy, but he annoys me sometimes. Can't deal with it.
Oh. I'm recording, so I can't say anything. I will not say nothing.
I hope they all tell him.
Oh. I couldn't imagine that. Tell your teacher to see if he can get out earlier in class. You got to test her. I think mine are, you can manage to get them done in 45 minutes. There's rarely ever time.
There's never, but this is like 30 multiple choice, half of them are stimulus based, and then 2 short answer questions with 3 parts each. So like last time I was like, and I don't know, I always study for my tests. Like I never come in unprepared.
Yeah, I know you do.
That's typically how it is, and I had studied for this test, but I do not, he expects like paragraphs for each part short answer question.
Yeah.
Like I don't want to say it's quantity over quality, but sometimes he is. Like even if it's a good quality answer, oh, you guys are creepy students. So I write, I write what I should, how much I should, but
just to get your point across.
Over 1 page, like for 3 parts, not for 1 part, but for 1 short answer question, that's 3 parts.
Yeah.
I see to analyze, whatever, all that stuff.
Mm-hmm.
I mean, that one yesterday took me more than a page front and back because it usually is like 1 page for 3 parts, and
yeah.
I don't know, it wasn't looking too good. I never do balance test with that one. I had like 5 questions I was saving for later. I scrolled out the rest of my short answer, just like wrote random stuff. Well, I mean, I hope it was alright.
Yeah. Oh my, what a guy. My college classes, oh my gosh, it was never just multiple choice. It was always a blue book. So like the vocab definitions, you had to do who, what, where, when, why, and significance, like impact. And just the vocab terms alone, usually had to do like 5 of those. And they would take up at least a page and a half just filling out one vocab term. And he'd give you like a list of 10. You could pick 5, which was nice. But, oh, man. Oh, it was tough. And then the short answer. So then he had 3 short answer. So that would take at least, and to write it in proper format and everything, that would take like 2-3 pages. And then the long essay, you had to pick one long essay, give you a shot at 2 of them. And that would take at least 5 pages. You'd leave there, and the whole blue book would be filled. And your hand would be, oh my gosh.
Like, I'm thankful he doesn't make us do the LEQs with our test. Like,
Yeah.
that I appreciate, because that would not be nice. But not be nice on his behalf, but on ours, like, that would be enjoyable. But his tests are like, he's even admitted it before. I try not to snap. Sometimes I reach my breaking point. Like, that time I really thought he said that. I was like, are you kidding me? I was close to losing it. Like,
for his test.
What?
For his test.
Well, sometimes I get there, but when I thought he
Oh.
I was really about to. It was not a good day for me already. I was already there, but it was
I'm sorry, we're
he
over
just
it.
needed to do one more thing for me to pop like a balloon, and then.
Oh.
Some days you get something out the test. Like, I had a college algebra test. And he just came up. We had this test for a week.
Yeah.
And then the day before that test, he's like, okay, guys, we're taking a test tomorrow. Leave your 7th period classes as early as you can to get started. And I said, I have a test in a college class before this. Like, you're coming up with it on the dot. I can't leave it. And he's like, well, what class is it? And I said, college algebra. And he's like, well, get done with the test as quickly as possible. And I was like, oh, you did not just say that. You really didn't. And I was about to lose it.
Who cares about that?
He's like, AP classes are weighted more than college classes. I was like, I was.
Oh, Nelly.
I had to take some time. Nobody confronts him about it, so nothing happens.
Every class is this serious, I take every class seriously.
I do. I don't care if it's an elective. If it weren't elective, I wouldn't leave it early for another class.
Yeah.
Because the 45 minutes that are allotted for that class.
Yeah.
And I know my teachers don't care. Because I have Miss Wolf. She's brand new. She's not going to be like,
oh, yeah.
No. But Miss Wren, like, one time I had to stay in her class to finish the test. He was mad. I brought him a slip. I was like, is it all right if I stay with her to finish this test? Like, snatched it out of my hand. He's like, we'll get finished with it. Don't waste any more time.
Are you serious?
He was like mad, but he does that to everyone else. I'm just saying.
Wow. Holy cow.
Every single test day.
Jeez. Only get on his bad side, huh?
Yeah.
We have a department meeting today, and I have a tea time at 3:10. I said, hey, do you think we maybe get this quick? We'll see. I'm like, all right. All right, so let's go over this real quick. Okay, so the nervous system, broken down in 2 different parts, which we talked about yesterday. We have the what? What 2 parts did we mention first with that nervous system? Andy, you remember? What's the first one? It's only broken down into 2 terms. That is easy.
The central nervous system.
Yeah, the central nervous system. I put it up as CNS, okay? The central nervous system, and that's broken down into what?
The brain and the spinal cord.
Yeah, the brain and the spinal cord. Good job. And then on the other branch, we have what? Michaela, Booker, what do you have? Well, not there yet. What is the other, I guess you could say, main topic? Yeah, peripheral nervous system. Good job. And that's broken down into what? Go ahead, Michaela. Yeah, good job. Somatic and autonomic. And what is the somatic? What's involved with the somatic nervous system? Yeah, voluntary movements. Good job. So we actually have to maybe think about these movements. Like I said yesterday, once we have a stronger neural connections with these types of tasks and maybe exercises, whatever it might be, okay, we can maybe not even think about doing these tasks. Like, it just happens, second nature, right? We don't even have to think about it too much. But there's still voluntary movements. It's like shooting a basketball, right? So after you continue to do that over and over and over again, it's like you can't miss, especially for Stephen Curry, right? You guys see that? Oh, man, he crushed it with the 3-point competition the other night. It was amazing. I think he hit the most amount of 3-pointers ever. It was pretty cool. Whoa, look at this. All right, thanks a lot.
Thank you for buying.
No, thank you. Oh, Nelly. I Can't wait to eat this. Oh. I won't eat it here, I promise. All right, so then we have the somatic. Then what? Autonomic, right? Now what's involved with the autonomic? Hannah, do you remember?
It controls the corporeal muscles, so that it fights.
Yeah, so the involuntary movements, right? Okay, so this is like breathing, digestion. Okay, these are the things that just happen automatically. We don't have to think about it. Sometimes it happens too fast. We can't control it. Oh, no. Can't make the bathroom quick enough. Oh, I'm just kidding. Yeah, so that's broken down into two sections then, right? What are those other two sections? Sarah, I guess we'll finish off here with you.
Sympathetic and parasympathetic.
Yeah, good job. So we have the sympathetic and parasympathetic. What's involved with the sympathetic?
The sympathetic expands energy, so it's like your fight or flight senses, or like as you say.
Good.
Parasympathetic conserves your energy, so it's when you're like calm and relaxed and not like, I don't know, fight or flight mode, I guess.
Yeah, good job. So sympathetic, we have, fight or flight, and this is where it's excitatory. Okay, our energy levels rise, our blood pressure, heart rate rises, and this is something that obviously perform with different types of exercises. This might be a scary situation, right? I think I talked about that. Watching a Scream movie or something. Look out, slasher, and this gets us excited, right? And our blood pressure rise, and in a way, I guess it creates anxiety for sure. And I think I gave the example yesterday, just driving on a sheet of ice or hydroplaning. Okay, how we respond in a fast, experience like that. So I had, fight or flight. Do we stomp on the brakes? Do we let it coast? What do we do, Sarah? Yeah, let it coast. Yeah, good job. Drift it, right? I'm just kidding. And then, we have the parasympathetic then. So rest and digest, I think I said this, conserves energy. Our heart rate, blood pressure goes down. Okay, and this is where we're relaxing. Okay, at the end of the night, we're about ready to go to bed. We flick on. I'm watching Gotham lately. I like that show. It's pretty good. It's about all the supervillains and Batman before Batman comes about. It's pretty cool. That's what I usually do. Parasympathetic kicks in, just relax. Then my cat attacks me, and the sympathetic comes out of nowhere. And I throw him around the room. All right, so there we go. That is nervous system basics, really. Okay, brief description of it. And I like you to know that. So that might be on the quiz or an assessment in the near future. All right, so 3 types of neurons. What do we have? 3 types of neurons. What was the first one we went over? Sarah, go ahead.
Interneurons.
Interneurons, good job. And what is their basic function?
They communicate with the sensory and their CNS neurons.
Yeah.
So, like, sensory neurons, they're in the brain. All the other ones are like throughout the body, and they outnumber the others 10-to-1 ratio.
Yeah, good job, right? So this is a connection between motor and sensory neurons, and most of them are located in the brain. Obviously, throughout your body, there's more locations of them as well, but for the most part, they're in the brain, and they communicate between the sensory and motor neurons. Good. All right, then we talked about the sensory neurons. What is the basic functions of the sensory neurons? Booker, what do you have? Yeah, good job. So this is sensing the world around us. Okay, the 5 senses. You want to put that down? That's great. And how we sense the world around us. So this is incoming traffic, right? So this is messages sent that maybe we put our hand on a stove or something. That information sent up to our brain. Okay, good job. So one-way ticket to the brain. What is the scientific name for that? That might be a question. What do we have for that one? Go ahead, Sarah. Afferent. Yep, good job. So make sure you remember that afferent neurons. All right, and then we have motor neurons, right? And what is the main function of the motor neurons, Hannah?
It sends the signal from your brain back down to your hand, telling you to take it off.
Yeah, good job, right? So this is the information that's sent from the brain to the rest of the body. Okay, organs, whatever, muscles, you name it. Okay, and that is sending that information one-way ticket to the rest of the body. Good. And I just did that scenario the other day, throwing the ball, seeing how all that kind of works together. you know, some cases it really quick reactions and reflexes, and also over time, you know, we build those neural connections to a point where we can do these tasks pretty quick and fast. It's like Spider-Man, an extra sense. He has a spider sense. He can see things coming from a mile away before it happens. No, I'm just kidding. I'm just kidding. All right, so how about I let you guys work on vocab for a couple minutes here, and we'll move on today with the parts, functions of the neuron. So how about, I don't know, 3 to 4 minutes? Does that work? All right. Let's see what we got here. I'm pumped up. Oh, yeah, drop the fork. Don't say anything. 5-second rule. Oh yeah. This is going to be good. All right, I think that's enough time here. So, I'd like you guys to turn to page 157, and it's just a short reading here. And I'd like you to take note of figure 6.2, because that's what we're going to be talking about, the neuron, its parts, and its functions. So, on your PDF, that's page 169. 169, okay? 157 in your textbook. But PDF, it's 169. So I'd like you to just read basic parts of the neuron, okay? We're going to talk about that today. And we'll get into it eventually. It kind of goes in a little bit of detail about synapses and how neurons connect. Well, not really connect, but send information back and forth. It's interesting. All right, so I'll give you some time, read basic parts of a neuron. It's in green there, and just look at 6.2, just to look over that and the different parts of it. So that's what we'll be talking about today. All right, so that should have been enough time. That shouldn't have took you too long. All right, so we're going to talk about the neuron today. We already know what a neuron is. Okay, we talked about that yesterday, and 3 different types of neurons. All right, we went over the inner neurons, we went over sensory neurons, afferent, okay, and motor neurons. And we went over the nervous system, so we should be good to go with that. All right, so I got to go back up here. There we go. All right, so neurons are cells specialized to receive, process, and transmit information to other cells. So bundles of neurons are called nerves. There we go. Like I mentioned before, they could be almost like microscopic in a way. Right? You can barely even see them. And in some cases in your legs, they're pretty long, the extent of your leg down to your ankle. It's amazing what they can do and how fast they transmit information from your brain to the rest of your body. Okay, and obviously to the rest of your body to your brain. All right, so with that being said, we're going to move on. So I already talked about the 3 different types of neurons with the sensory, motor, and ender. I think we're good with that. So a neuron exists to perform 3 tasks. 1, receive information from the neurons that feed it. So we all need to obviously have that ability where we can send and pass information at a fast pace. Okay, whether it's reacting to certain things, whether it's visualizing information, whether it's understanding and grasping knowledge, whether it's performing an exercise, whatever it might be. Okay, that information needs to be traveled along and sent from neuron to neuron. If not, then that message probably won't send. Okay, we won't be able to perform that task. Okay. 2, carry information down its length. So we're going to discuss that process today and how that is being used and how that information is going to be passed along at a fast rate. 3, pass the information on to the next neuron, which we'll talk probably more tomorrow since I want to get you working on the activity today. So that occurs through synapses. They actually don't connect. It's more just passing information and seeing if anything seeing if that message will be received by the receiving neuron. And if not, there's a process called reuptake, which we'll talk more about tomorrow. All right, we already talked about the motor neurons, interneurons. Okay, and here is what the neuron looks like. Kind of looks like that thing from Alien, right? Do you guys ever see the Alien movie? Or the baby from it attaches onto people's faces and it sends like an egg down its throat, like people's bodies, and then an alien pops out. It's pretty crazy looking. And that's what it reminds me of every time I see it. The long tail wraps around and constricts the person's neck. It's a crazy thing. All right, but the first part of the neuron I want to talk about is the dendrite, the receiver. So in order to try to transmit information, all right, you need to have a part of that neuron that receives information, that branches out and that attaches to other neurons in order to receive it, pass that message on. So the dendrite, that's its part, that's its function. It branches out from the soma, which we'll talk about next, but these branches are used to connect to other neurons. And as you can see, there's multiple branches stemming off that soma, because once we perform a new task, like I said, and once we practice the task over and over and over again through practice and repetitive actions, we have a stronger bond. We have a stronger neural passageway where that information can be passed at a faster rate. So dendrites have the ability to connect to multiple different neurons. It's interesting how it works. But those dendrites, they stem off. They're like branches. They're like arms, and they receive the information from another neuron. Always related to football usually. Okay, obviously to move down the field fast, you have a receiver out there. He catches the ball from the quarterback. So he's receiving that ball so you can move down the field at a faster pace. Okay, it's vital to have a passing game in football. So dendrites the receiver. They receive that incoming information, that message from another neuron. You guys good with that? All right, so dendrites receiver. They branch off the soma, okay? The soma. That's just another name for a cell body, okay? So the cell body, I'll just go back to this picture here. The soma is this part here that obviously the dendrites branch off of, okay? And they receive the incoming information from the dendrites. And that's processed in the nucleus. So the soma, the cell body, its main function is just a housing of the nucleus where that information is being processed. Okay, so the dendrites connect to that soma, that cell body, where that information passes from another neuron into a dendrite down to the cell body, the nucleus, where that's going to be processed. What's up?
So when it says selectively permeable, does it mean like the cell membrane of the soma is like, because we learned about that in bio, like some macromolecules can't get in there, like if they're too large or if they're polar, then they can't get through. Does it mean like through the cell body itself, or like the dendrite can sense what messages it is or isn't?
Yeah. Yeah, so the dendrites actually have the ability to accept what type of information comes through to the soma and the cell body. So that's what that means.
Like if it's like a specified.
Yeah.
Okay. I didn't know if it meant like dendrite itself or if like
The cell body
membrane
has like microscopic spaces to allow information to come. Is that what you mean? Or like any type of other material? Yeah, so usually the cell body is pretty, I guess you could say, it has the ability to branch off. I think that's kind of what I want to get at, is that it has the ability to create more dendrites to connect to other neurons. So that's kind of what I'm trying to get at with that part. So like when you perform a new task, more dendrites branch off of it, and then you'll see a stronger neural connection. Okay, I have a video. I don't know if I can get it. It's the part of it's really long, and the guy kind of talks like a weird way, so it's not fun to show. But it actually shows how the dendrites over time, kind of merge out of this soma, and it's interesting to see the connection to other neurons. And like when a baby, especially, I think that's the way the thing that organism that they're looking at, when it makes more neural connections and performs new tasks over and over again, you can see the dendrites actually forming out of the soma and connecting to other neurons. So that's what that means. Yeah. All right, so the cell body, okay, the main thing, it receives that information from the dendrites, and the nucleus is housed in that cell body in that soma. And obviously we know the nucleus is like the brain where this information is being processed inside that cell body. So the nucleus is receiving this information and deciding whether or not we should send this information, okay, down the axon, which we're going to talk about next. So we know the nucleus processes this information housed inside the soma in the cell body. And once that information is processed by the nucleus and it's able to be sent and transmitted to another neuron, it's sent down the axon. Okay, this is the axon here, this long axon fiber. Okay, this is a fiber that connects to the soma to the axon terminals, which we'll talk about a little bit more. But this is a one-way road. Okay, there's no sending it back up to the nucleus. Okay, once it's fired, there's no going back. right? A one-way road. I know some of you like to maybe break the law and drive up those one-way roads, right, Sarah? No, I'm just kidding. I'm joking. But the axon doesn't allow that to happen, all right? Which we'll talk more about when we talk about the firing of a neuron. But the axon is that one-way road, that one-way highway, okay, that is sending that information down the slope of the axon to the axon terminals. No, we're good. We're good. All right, so here's a little bit more of information. Extension of the neuron through which neural impulses are sent. Okay, this is kind of a cool saying. Axons speak, which they are the sender of the information. They're like the messenger, okay? And then the dendrites listen, right? They're like the ear. They listen, they pick up that information from another neuron. I think that's a pretty good statement to express what the axon does and what it accomplishes, what its functions are. So this is interesting. So in some neurons, like those in the brain, axons are very short, very microscopic. Okay, we all know that some of these neurons, with all the connections with the interneurons, they're very short and very small. But like I mentioned earlier, okay, in others like in the leg, they can reach up to 3 feet long, which is amazing. Wow, it's crazy how long they can actually extend. Did I get to Axon Terminals yet? I don't think I did. Oh, here we go. I want to talk about this. Sorry. So I'll go back to the other slide. That's more with the firing of a neuron. The myelin sheath. Okay, the myelin sheath is this outer protection of the axon. Okay, this is protecting the axon and actually allows, there's microscopic spaces inside this myelin sheath that allows for a charge to be sent. So this impulse to be sent at a faster rate. And we'll talk a little bit more about that tomorrow. But with the myelin sheath, this is really just the protective shell of the axon. And a good example of a myelin sheath would be like an extension cord, right? So we all know the extension cord has fibers in there that connects an electrical signal to whatever you're trying to operate. But there's an outer coating on it, right? That outer coating protects, right, that the axon, right? And an electrical cord, obviously, it protects it from sending that information, that electrical charge, to whatever device you're operating. The myelin sheath acts right like that extension cord coating. It protects the axon and makes sure that it's not damaged. Okay, they can send information to other neurons.
Have you heard of Matt Lipsy?
What's that?
Do you know who Matt Lipsy is?
No.
He's like, you know, Clayton Bouchard, the runner.
Yeah.
The track coach. He's one of his running buddies. He's like a really good runner, and he has some like disorder where the, I don't know, pronounce it myelin sheath of his I guess you could say his neurons were just like he couldn't figure out what was wrong with him. He just randomly lost all his energy, like running 10 miles a day till he couldn't like walk down the stairs.
Oh my gosh.
He had no clue why, and it turns out that was one of the problems, was that it's like wearing away.
Wow.
So it was all because of that, like, I don't know, that sheath on the outside, I guess, when it starts to deteriorate. I know there's something else that can happen, some other disorder where you act erratically, but his like weakened his immune system, and he was like so weak he couldn't walk.
Wow.
Just because of that.
There you go. That's very important, obviously, then a part. That's so sad, though. Jeez.
I think he's like recovering because his doctors, like, they couldn't figure out what it was at first, but they finally identified that was the issue, and they're like working on fixing it. I don't know what he does now, but
I was going to say, how do you even repair that? Like, how do you?
I'm assuming some sort of
Substance or?
something that would encode like production of Schwann cells. I'm assuming.
Wow.
Probably something that stimulates that. I would guess. I don't really know, but that's kind of what I think.
Yeah, that's interesting. I never heard of that. Wow. Huh. Yeah, that's very interesting. Yeah, so the nodes are Ranvier. Okay. Hold on one second. Okay, yeah, this is the last thing I want to talk about, and then I want to mention the axon terminals then. The nodes around V are these microscopic spaces inside the on the myelin sheath that allows for action potential to occur. That allows for the information to be sent down the axon. It really just provides the energy for this to occur. Okay, it provides for the ability to send this information to other neurons and helps with the communication of our nervous system. So nodes around V are really just microscopic spaces inside and a part of the myelin sheath. Okay. I can't believe that yet. Oh my gosh. Yeah, it is. Yeah.
Like long trail races, like crazy stuff. Have you heard of like a VK?
No.
Marathons, you like on straight up mountain, like all this like crazy stuff. And he just went from that to he couldn't even like walk down the stairs. Like he was just so weak. Not like in pain, but just like weak, like muscles weren't working. Stuff properly. And
Wow.
they figured out that that's what it was. So I guess it has something to do with the lack of, I don't know, like ability to do, because it's like when you're doing anything, it's all these signals going through the body. So
Yeah.
something to do with that, like the signals probably weren't reaching properly or something. Couldn't do anything. It was too weak to open a jar of mayonnaise. I read an article. He was interviewing guys like I couldn't even walk downstairs.
That's unbelievable.
It's pretty crazy.
So he is recovering though? From
Yeah.
Okay. I don't even know how you would even help that. That's tough. Oh, my. Yeah. Oh. Okay, last thing, guys. So obviously branching off the axon. Okay, we see even other, we see fibers here. We see other branches stemming off the axon. And they're called axon terminals. Okay, you can just write that down. Axon terminals. I don't think I have a slide for it. But axon terminals, they are sending that information to other dendrites, right? They connect to other dendrites. They don't actually connect, but it's pretty much they connect, okay? They connect to other dendrites where that information will be received by the other neuron. Okay, so these axon terminals, they branch off the axon and they connect to other dendrites where that information can be easily sent to another neuron. Ooh. All right, is there any questions on that? You guys good with the parts and functions of the neuron? All right, so I have just an activity for you. Just try to fill this out for tonight. Shouldn't take you long at all. Just use your notes to help you out if you get stumbled on it or whatever it might happen. And that's up here Wednesday, 3:10. Neuron activity. It's a PDF. I don't know how that will work now since PDFs, I guess, are whatever. Can you see it? I don't know if you can see it or not. You can?
Can't see it, but you can't edit it.
Oh, so if you can maybe take a picture of it, a screenshot of it, and then edit it that way. That's probably the easiest way to do it. Or if there's another application that works, feel free to do that. Or if you just want to write in your notes, that's fine too. All right, so you're going to just label it here. So obviously it's asking for number 1. You just label what it is and its function, its part, okay? That's all you do. There we go.